We all recognize this iconic silhouette, the majestic Stegosaurus. For over a century, we thought we understood its most famous feature, the plates. But what if I told you they made for a terrible shield? They were thin, riddled with blood vessels, and left the spine dangerously exposed. So what were they really for? A fortress of bone? A vibrant, living billboard? Or a sophisticated climate control system? The truth is a fascinating puzzle, hiding in plain sight for 150 million years. The air is thick, heavy with the scent of damp earth and crushed ferns. You stand at the edge of a vast floodplain, where colossal ginkgo trees and towering cycads punctuate a sea of green undergrowth. The sun beats down from a sky you wouldn't recognize, unfiltered and immense. On the horizon, a procession of impossible shapes moves with a slow, deliberate rhythm. They are living mountains, crowned with a bizarre and beautiful architecture of bone. As one turns, you see it, the iconic silhouette of giant, kite-shaped plates rising from its spine, a jagged fringe against the Jurassic sky. Ever wonder what it truly felt like to stand in the shadow of a living giant? Let us know in the comments where you're watching from, and which prehistoric creature captures your imagination the most. Now, let's journey back in time and uncover the story of a lost world. You are 150 million years in the past, in the late Jurassic period. This world, which will one day become Western North America, is a vibrant, dangerous Eden. The ground beneath your feet belongs to the Morrison Formation, a legendary deposit of rock that has gifted us some of the most famous dinosaurs ever known. And before you is one of its undisputed icons, Stegosaurus. Its name, a gift from the Age of Discovery, means roofed lizard. This came from the very first interpretation of its fossils, where paleontologists imagined these huge plates lay flat across its back, forming a kind of armored roof, like shingles. A charmingly incorrect first draft of a magnificent reality. You watch as the 4-ton animal lowers its head to browse on low-growing ferns. Its head is astonishingly small for a creature 9 meters long, housing a brain famously no larger than a lime. Hollywood loves to joke about its lack of intellect, but survival for millions of years requires more than just brain power. It requires perfect adaptation. And every part of this animal is a testament to that, a piece of a puzzle we are still trying to solve. Your eyes are inevitably drawn back to those plates. They aren't overlapping tiles at all, but 2 rows of bony marvels, standing upright and alternating down its powerful, arching back. They seem too thin, too intricate for a simple shield. So what were they for? This question has sparked over a century of scientific debate, transforming this gentle herbivore into the subject of a fascinating paleontological mystery. Were they a fortress of bone? Or a vibrant, living billboard? The air suddenly feels colder. The gentle munching of ferns stops. The herd around you grows still, the great bodies tensing. You follow their gaze toward a line of dense conifers and see a shadow detach itself from the trees. It's a predator built with terrible efficiency. An Allosaurus, the lion of the Jurassic, its massive skull filled with blade-like teeth. It moves with a terrifying grace, its powerful legs eating up the ground between you. Now, the question of the plate's purposes feels less like a debate and more like a matter of immediate survival. The first and most obvious theory seems to lock into place. This is armor. You are looking at a walking fortress. Imagine the view from the predator's eyes. The Stegosaurus is no longer just a wall of flesh. It's a barricade of bone. The plates, rising nearly a meter high, dramatically increase the animal's profile, a clear "do not attack" signal. They create a visual illusion, making the herbivore seem taller and more formidable than it truly is. More importantly, they present a jagged, uneven surface. A predator like Allosaurus would typically attack from the side or above, aiming for the vulnerable spine to deliver a paralyzing bite. But here, that vital target is protected by this double row of bony shields. They may not be thick enough to stop a direct, full-force chomp from a 3-ton carnivore, but they don't have to be. Like the wicker shields of ancient warriors, their purpose might be to deflect, to complicate, and to make the attacker hesitate. But the plates are only half of the defensive story. As the Allosaurus circles, looking for an opening, your attention is drawn to the Stegosaurus's tail. It lifts clear off the ground, held taut and muscular, ready to swing like a medieval mace. At its tip are 4 enormous spikes, each up to a meter long and sharpened to a deadly point. This lethal weapon has a wonderfully modern name, the Thagomizer, coined not in a stuffy museum, but in a beloved newspaper cartoon. Science, it turns out, has a sense of humor, and the evidence for its use is chillingly real. Fossils have been found. An Allosaurus tailbone with a gaping infected puncture wound that is a perfect match for a Stegosaurus spike. This was an evolutionary arms race made real, and the Stegosaurus was fighting back. The plates guard the body, forcing the attacker into the arc of this deadly swinging tail. It's a brilliant 2-part system of passive and active defense. But is it the whole story? And yet, as you watch the confrontation unfold, doubts begin to creep in. The fortress theory feels solid, but it doesn't quite account for the elegant, almost delicate structure of the plates themselves. They are positioned in 2 alternating rows, leaving a significant gap right over the spinal column they are meant to protect. They are also surprisingly thin in places, and internally, they are not solid bone, but a honeycomb of bony struts. For a dedicated shield, it seems like a rather poor design. Evolution is rarely so inefficient. Perhaps we've been looking at them all wrong. What if their primary purpose wasn't to stop a predator, but to send a message? What if you're not looking at a fortress, but a living billboard? Let's re-examine those plates not as armor, but as an advertisement. In the vast, crowded landscapes of the Jurassic, being able to recognize your own kind from a distance is crucial for survival, for finding mates, and for maintaining the herd. No other dinosaur had a silhouette even remotely like this. The plates were a unique, unmistakable signal. I am a Stegosaurus. They could have also been a key to the social lives of these animals, like the antlers on a stag or the brilliant feathers of a peacock. Bigger, more impressive plates might have signaled dominance, health, and genetic fitness to rivals and potential partners. This idea gains incredible strength when we look closer at the fossils. The surfaces of the plates are covered in a complex network of grooves. For decades, scientists puzzled over these markings until microscopic analysis revealed their true nature. They were channels for blood vessels, an enormous number of them. This changes everything. It means the living plate was not a dead piece of bone, but was sheathed in skin and coursing with blood. By controlling the flow, a Stegosaurus could have flooded its plates, causing them to flush with vibrant color in an instant. Imagine the dull, earthy tones of its hide suddenly contrasted by a dazzling, intimidating blush of red or orange along its back. It's a breathtaking thought. This rich blood supply also points to another fascinating possibility. The plates were a sophisticated climate control system. For a multi-ton animal, overheating was a constant danger. By pumping hot blood to the surface of these huge, skin-covered plates and angling them into a breeze, the Stegosaurus could have shed excess heat, just as an elephant uses its giant ears today. Conversely, on a cool morning, angling the plates toward the sun could have turned them into solar panels. warming the blood and helping to kickstart its metabolism for the day ahead. Shield, billboard, or radiator, the mystery only deepens. The Allosaurus, seeing no easy opportunity, retreats back into the shadows of the forest. The tension breaks, and the herd resumes its slow, ponderous journey across the floodplain. To truly understand this animal, you must walk with it, matching its unhurried pace. You are moving through a world both familiar and alien. There is no grass beneath your feet. It has yet to evolve. Instead, there are vast prairies of ferns, some as tall as a person, stretching to the horizon. The climate here is seasonal, swinging between a lush, monsoonal wet season that turns the plains into a network of swamps and a harsh dry season where food and water become scarce. This rhythm dictates the life of the herd, forcing them on long migratory journeys. You watch as the Stegosaurus beside you dips its small head. With a horny, toothless beak at the front of its mouth, it snips off the tough fronds of a cycad, a plant that looks like a short, stout palm tree. Its low-slung head and stiff posture mean its world of food exists within about a meter of the ground. It can't reach the high branches of the conifers, so it focuses on this dense undergrowth. As it begins to chew, another puzzle presents itself. Its cheek teeth are small and leaf-shaped, surprisingly simple for an animal that processes hundreds of kilograms of fibrous vegetation every day. They were for slicing, not grinding. So how did it digest its food? The secret lies deep within its belly. Like many modern birds and crocodiles, Stegosaurus likely swallowed stones, known as gastroliths. These stones would collect in a muscular part of the stomach, a gizzard, which would contract and churn, using the stones to grind the tough plant fibers to a pulp. It's a brilliantly low-tech solution to a biological problem, a food processor made of stone. This animal was a walking fermentation tank, perfectly engineered to convert the tough Jurassic foliage into energy. As a primary consumer, it formed a vital link in the food web, a mobile feast for the carnivores that stalked this land. Its existence supported apex predators like Allosaurus and Ceratosaurus, making its role in this ecosystem absolutely critical. Living together in a herd wasn't just for company, it was a strategy. More eyes, more waving tails, more plates to confuse a predator's charge. It was a community built for survival. The fern prairie dissolves, the herd fading like a ghost into the mists of time. 150 million years flash forward in an instant, and the rich, living landscape is replaced by the dry, dusty rock of the American West. Here, in the late 1800s, our modern journey with Stegosaurus begins. It was a time of great discovery known as the Bone Wars. A fierce rivalry between paleontologists to unearth the most spectacular prehistoric monsters. It was in this feverish atmosphere that the bones of the roofed lizard were first found and named by Othniel Charles Marsh. The initial fossils were jumbled and incomplete, leading to a series of fascinatingly wrong ideas. We've already seen how the plates were first imagined lying flat. Another early sketch gave the animal 8 tail spikes instead of 4. Perhaps the most persistent myth born from this era was that of a second brain. Scientists discovered an unusually large cavity in the hip vertebrae and, baffled by the tiny skull, proposed that Stegosaurus needed a supplementary brain in its rear to control its massive hind legs and tail. It's a captivating story that has stuck in pop culture for a century. But the reality is less science fiction, and even more interesting. This space likely housed something called a glycogen body, a structure found in modern birds that stores energy-rich carbohydrates. It wasn't a second brain, but a biological battery pack, providing a quick energy boost to its powerful tail and legs. So after this long journey, where do we land on the great plate debate?
Second brain.
Defense, display, or radiator? The most satisfying answer, and the one most paleontologists now agree on, is all of the above. Evolution is rarely about finding one perfect solution. It's about creating brilliantly versatile tools. The plates of the Stegosaurus were a masterpiece of multifunctionality. They provided a formidable visual defense, making the animal look larger and protecting its spine. They served as unmistakable billboards for species recognition and social display, perhaps flushing with color to communicate. And their internal plumbing made them perfect devices for controlling body temperature in a harsh, changeable climate. They are not a single-answer mystery, but a beautiful example of evolutionary complexity. It is this combination of the formidable and the fascinating that has made Stegosaurus an enduring icon, a symbol of a world so alien, yet governed by the same rules of survival we see today. The light begins to fade on the Jurassic Plain, and the giants of the past recede once more into deep time. Their bones, now resting in quiet museum halls, are all that is left of their magnificent reign, silent monuments of stone and memory. Yet to stand before them is to feel a powerful connection, a faint echo of the thunderous footsteps that once shook the very ground on which we now stand. These creatures were not monsters from a fantasy tale. They were a real and spectacular chapter in our own planet's history. And with every new fossil unearthed from the rock, their story becomes a little clearer, reminding us that the Earth holds endless wonders, with countless secrets still waiting to be discovered just beneath our feet.